quadratics. So let's go ahead and write this up here, ax squared plus bx plus c. So the equations now will have this middle term that's been missing up to now. Let me turn that music down. All right. The idea today is that instead of moving vertically, we are going to start moving horizontally. Again, what does horizontally mean? It means we're moving in this direction. What's going to do that? The b value is going to do that. Okay? Remember, c is what moved things vertically. So let's remind ourselves of where we have come so far with parabolas. So here we have a quadratic function. Notice it's written with a function notation as opposed to just the plain old y. We have an a value and a c value. Does this parabola go up or down? Is it wide or narrow? And has it slid upwards or downwards by how much? Hopefully you've circled each of those. And we should have said it went down. It is narrow. And both of those I'm getting from the -3. And then we slid up 6 units. And that's coming from the 6 at the end. This is 8-1, and this is 8-2. Now, one of the things we talked about on 8-1 and 8-2 is the line of symmetry. If I were to sketch this parabola right now, I would say, oh, the parabola is up here. It's downward and skinny. All right? What I'm going to change a little bit is that we are not going to be centered in this unit. Okay? Ugh, should have drawn that with one line so I can move the whole thing. Let's try that again. Ugh. All right. Now, if we take this parabola and shift it, right, we are not centered on the axis anymore. So what we need to think about here is if all I tell you that there are 2 spots where the graph crosses the x-axis, where is the line of symmetry? Remember, these we called the zeros. So again, we don't know, is the parabola a wide one? Is it a tall, thin one? Right? We don't know which direction it's going, but we do know that they're there. So based on the zeros, we can find what we call the line of symmetry. And if we look at the distance here to here, that was a distance of 4. So we know that if I break that into half, my line of symmetry is right here. So I can tell that as long as my units below are 1, the line x equals 1 is the line that's going to cut it in half. That make sense? All right. So here are our steps for graphing this parabola. I think it's really important, number 1, that we establish what are A, B, and C in the problem. The next thing that we need to work for is using those values, where is the line that cuts it in half? And this is the formula that you're going to use. Using those values, you're going to take the opposite of what you have for B, divide that by twice A. And this is the key to unlocking where is the middle. Where's the halfway line? Once you have that x value, we're going to plug that in because we know that the vertex will be on that, and we know the vertex is the most important point. So then the only question is, how do I find the y value? Well, to find the y value, just plug the x value into the equation. All right? Then I'm going to show you how to find 4 more points, which would make a total of 5 points for this parabola. You'll have a really good idea of what it looks like at that point. So here's our first problem. We want to analyze and graph y equals x squared plus 4x plus 3. All right, so what is A? What is B? What is C? So A equals -1, B equals 4, and C equals 3. So that's the first thing you should always do. Next, write down some words. What do we know about it now? Does this parabola go up or down? Down. Why? Because the A value is negative. It's also -1, which tells the graph is not wide, it is not skinny, it's normal. And finally, I see that I have shifted up 3 units. All right, line of symmetry. -b, which is 4. So what's the opposite of 4? -4. Divided by 2 times -1. When you do this part of the problem, always do the bottom part first on your calculator. What is 2 times -1? -2. What is -4 divided by -2? 2. So we have found the line of symmetry. Please list it always. Notice how I wrote x equals 2. Okay? It's really important that you write it as an equation. So it's not just 2, it's x equals 2. All right. Well, now that you have that, we know part of the vertex. So just list it out. We know the x coordinate is 2. How do I get the y coordinate? Well, you're going to do that from the equation. So again, I'm going to go back to the equation, and I'm going to plug in my x value, 2, into those spots. And I'm going to write it out as I see it. So -2 parentheses squared plus 4 times 2 plus 3. So this gives me -4 plus 8 plus 3. Hopefully you get an answer of 11. No, I lied. You get 7. Very good. We have found the vertex. 2, 7, the most important point. I'm going to zoom into here because one of the questions they're going to ask you, is the vertex a minimum or is it a maximum? In this case, I think we have a maximum because if you recall, very at the beginning of the problem, we said this graph goes downward. So this is a mountain type graph, parabola. It's like this, right? All right, so that means I don't have a minimum value, I have a maximum value. Okay, why? Because the vertex is at the top and this graph goes downward. So now, we're going to find some more points for this parabola. Usually, remember we talked about how this is a really good starting spot? This is no longer a good starting set of values for my domain. The graph might be useful with those values, but maybe not. Our vertex is a hint, so take whatever value it is you have here and put that 2 in the middle. And then go ahead and fill in the consecutive values on either side of 2. And because we know this is a parabola, these 2 values will be the same values, and these 2 will be the same values. So if you're lazy or in a hurry, you could just do those 2 values And as long as you're accurate, then these values will be the same. So y equals, I'm going to plug in 1 into this problem, just like I did the 2. Wherever I see an x, I put a 1. And hopefully you get that. Again, this is going to be negative 1 plus 4 plus 3, which I think is 6. So I know the 3 is going to give me 6. Plugging in 0, you can actually do just maybe with looking at the problem, because if you put a 0 here or here, they disappear. So all I'm left with is 3. So if you ever get a chance to plug 0, that's a nice, easy one to do. And again, because of symmetry, I know the last one's going to be that. Finally, I need to sketch sometimes this parabola. So where should I sketch it? Again, this will not always be a useful set of axes. Sometimes we're going to have to change them around. Sometimes you might want the x-axis up here and the y-axis, say, over here. Because of my settings of my values that I have, 0 to 4, I'm going to say the y-axis should be somewhere in this region. These are all positive values, so the y-axis should be down here somewhere. Where you put it, it's kind of up to you. I'm going to snug it up kind of close. I don't think I need to be really careful. All right, so 1, 2, 3, 4. This is the x-axis. I don't need to go beyond 4 because I see that my largest and smallest values in the domain are here. Okay. On the y-axis, I got to go up to 7. I think I have enough to get to 7. We do. Okay, so this parabola is going to fit. All right, 0, 3. 1, 6. Again, I'm using each of these pairs of numbers to graph the 5 dots. 2, 7. 3, 6. And then 3. This isn't a dot-to-dot game. This is a curve, remember? So you don't want to go like this. Instead, try to make it one nice, smooth curve. All right. Last thing that we're going to talk about for this problem is what's the domain and the range. Notice domain values. That refers to x, right? What x values are we using? Well, I could use any x value I want. This parabola will just continue to go down, 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 down. I would just need a larger graph to build it. So most of the time, I would gander to say 99% of the time, if you're working with a quadratic, all real numbers is your options. You can choose any value you want. Just that we pick these values because they're convenient to draw a picture with. We see the important part of the parabola. What about the range? This is what's going to be different every time. Your range, remember, is the y values. So we're looking at the y-axis. Didn't label it here as a y. So what y values am I using? Notice the graph goes down, 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 but it doesn't go all the way up. In fact, it goes up to here and then it stops. So that is the maximum y value, 7. So from 7 downwards is what I need to say. So y has to be less than or equal to 7. All right, well, there you go. There's another example here. If you do that, you're going to get x equals -1 for the line of symmetry. The vertex will be -1, 2. Okay? And this is an upwards and skinny graph. So it's probably good if you put the axis about here. No, that's probably going to have to be lower. That's our parabola, and it goes upwards and it's skinny. All right? So I think you're going to get dots there and there if you count by ones. The next dots are going to be off the charts. So you won't be able to graph the next other 2 dots. The range is all values greater than or equal to 2. And this is all reals. All right, hopefully that was useful and that made sense. The problems, I've given you workspace over here to show your work in terms of creating these problems.